The Windows Debugger is a program named Debug, and it's very old. It dates back to the early days of DOS, but it's still included with current versions of Windows, and you can use it if you stay aware of its limits. You can debug an exe file, but there is a preamble of code inserted at its beginning, and you will have to step through that to get to your code. If you assemble source into a .com file, they're a lot easier to read and to load up. You may remember from an earlier lesson that the default format produced by NASM on Windows is a .com file. This example that I'm going to use was produced from this command. Notice that the assembler also provides a listing file. That's so you can take a look at the actual object code generated. This is the code to be debugged. It's an algorithm to find the greatest common denominator of two values. In particular, notice the values that appear in front of the 32-bit opcodes. The 66 byte is a preamble byte to let the CPU know that what follows is a 32-bit operation. Here at the very bottom are the two integers declared with the initial values to be used in the calculations. To use debug, you specify the full file name of the program to be loaded into the debugger. Once it loads the program, it positions to the first instruction in it and stops, using a single minus sign as the prompt for input. The letter U is short for unassemble. The debugger disassembles the code it finds and lists the results for you. Notice what happened to those 32-bit byte preambles. The debugger didn't know how to disassemble them, so it simply put them in as declaratives. You can run the program with the debugger this way if you want to. The P, which is short for proceed, will execute one instruction and then pause again. Disassembling the program now will show you that it has advanced to a new location, but there is a better way to do this. If you go to this website, you can download the new version of the debugger, one that handles 32-bit instructions. It's called Debug X. It's part of the FreeDOS project. It works the same way the old debugger does, but it understands 32-bit instructions. Now, when you load gc.com into the assembler and unassemble it, you get the instructions the way they were originally assembled, and that's a lot easier to work with. You can see exactly what you've got, and this debugger works exactly like the other one. You can use T for trace or P for proceed. They both step forward one instruction, then stop and show you the register values. The only difference is T will trace inside a function call if it comes to one, and P will skip over it. Or you can use R to look at the register values without moving. As you can see, the two integers to be used have been loaded into the EAX and EBX registers. There are lots of things you can do. Entering a question mark will give you a list of a couple of screenfuls of instructions. You can assemble code, perform hex dumps, set breakpoints, execute to specific addresses, and lots of other things. What you do depends on what you're looking for. Everybody has a different approach to debugging.